Good afternoon. Is the screen visible?
Good afternoon, sir. That is
Yes.
visible.
Thank you. Okay, so before going to the topic, I'll like to share some information with you. So far, some students, yeah. So most of the afternoon batch, I have received the um, list of papers, and I'm just working on it. Okay. For few batches, I have replied with the possible changes, required changes I have just shared with them, right? And I send a mail for those teams who need changes. I have sent a mail directly from my official mail ID, and I demanded them to send a mail back to me with the additional papers that has to be replaced, only the list of replaced papers. But what happens is they have again uploaded the same into the Google link. I never asked you to upload. I asked you to send me the file, reply, okay, to the mail. So, and for those who have done it, I'm going to delete that entry from the collected list of papers from the Google document. Okay, so I request them to send a mail to me, reply to my mail with the list of changed papers. Just reply, not even write a new mail, just reply to my mail, so that I'll get notified and keep that changes with me. I don't say anything about those changes. Remember, you need to look for only journal papers from reputed journals. Reputed journals, that's why I just gave you instructions, enough instructions I have shared how to download those papers. And one simple way to search for the papers is you can have some basic knowledge about the domain that you have chosen. Then have the keywords with you, use those keywords to search for the papers. Okay, so once you get one paper, most of the papers after the abstract section you will see list of keywords, so you can use those keywords to enhance your search, to search further for set of documents. If you do that, you will get most recent papers in your problem domain. And also, especially if you go with the uh, this elsewhere and IEEE, if you click on that paper which you are interested in, definitely it will suggest you similar papers. The system automatically suggests you similar papers. So in that direction also you can search. So ultimately, I don't want to have conference papers. Okay, I don't want to have conference papers. I don't want to have the papers which are old, maybe like not before 2018. Okay, even 2018 also I will cross verify. If you send a paper to me, I will cross verify whether don't we have any latest work in this particular domain. If I find any more papers other than the list which you have shared with me, that will affect your marks. Okay, so that's why I'm telling you, for review 1 mark it will affect you. So first collection of papers that you have sent me, no problem, that not at all an issue, but I replied with you. So I have accepted some paper, I have rejected some paper. What is the reason for rejection? It's either conference paper or a survey paper or a study, some kind of studies. Now COVID, due to COVID, there are a lot of studies are there. Okay, so what is the sentiment of these people? We are want to study that one. So what is the effect of effect of COVID on business, this kind of business, like these are all the study papers. They don't give you enough input. Okay, so those kind of papers and old papers, right? So these papers I have rejected, and I asked you to find a replacement for those papers that you are going to do. And remember, don't upload the changes into google google link again. If I send a mail to you, you reply to that mail. So I'm just sending the mail to individual teams. Those team leaders are responsible to get me back the list of papers. And remember, it is your job to carefully choose the titles this time. Okay, the second time you have to choose very carefully, because I'm not going to reply you on whether it is acceptable or not, but I will take it into consideration during the first review evaluation. Not now, but first review evaluation I will consider for that one. Okay, so please keep that in mind and do accordingly. And remember, I told you I'm going to delete the entries from the Google link. So those who have uploaded again for the second time after getting my mail, you have some of you have uploaded into into Google link. Those I ask you to send me the file to me, reply me the changed lists. Okay. Any doubts? Any doubts?
No, sir.
Okay. Mohammed Anas.
Yes, sir.
Yes, it shows. Why it shows you are away from there?
No, sir.
Zain Ziad.
Yes, sir.
Are you there? Where are you from?
Sir, from Kerala.
From Kerala. Okay. Okay, so next topic is text pre-processing. In natural language processing, text pre-processing is one of the important steps. Most of the applications, most of the processing, natural language processing, we go for initial stage, certain things like segmenting the given text into paragraphs and sentences and individual words, or we are going for normalization, we are going for um, removing the stop words, going for identifying the keywords. So these are the usual pre-processing steps that we follow in any natural language processing. So first thing is actually we need the data to be in computer formats, digital bits, right? And the linguistically meaningful units. That is converting the text pre-processing. It helps us to convert the raw text into sequence of digital bits. It is crucial because characters, words, and sentences identified at this stage is used for further processing. So we want to understand what are the words used, what are the characters, how the sentence is formed. Then we can go for next stage, this syntactic parsing. Then we can go for move to the semantic understanding and so on. So that is required, very much required. So we are doing text pre-processing, and we have two stages in text pre-processing. One is called the document triage, the other one is called text segmentation. So what is document triage? It's converting a set of digital files into well-defined text document. Converting a set of digital files into well-defined text documents, right? So very first thing is, how do we perform this document triage step is, it has several steps. So very first requirement is the characters in a file must be machine readable data, right? For example, character encoding, you must know, I think, about these ASCII characters, right? American Standard Code for Information Interchange. This is the way to represent the English characters, English alphabets, that is lowercase letters, uppercase letters, numbers 0 to 9, and some special characters. Okay. So this is the reason is the computer can understand bits and bytes. It cannot understand any text that you are feeding into. Okay. So very first requirement is characters in a file must be machine readable, machine understandable, because our task is to make the computing device to process the natural language. To process the natural language. So very first, very basic requirement is character encoding. And the second thing is character encoding identification. Okay, first thing is machine readable. Second is character encoding identification. Which type of character encoding is used in this document, right? For example, if I'm going to type something in Tamil or in Hindi, the system must be able to understand whether it is written in Hindi or Tamil. I need to know the character encoding. Then only I can properly convert the into a local format that is understandable, machine readable format. Okay, so it may be in ASCII characters, but ASCII characters are very limited. Very limited. Initially, we have started with ASCII characters. Then we have Unicode. 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 It supports all the languages, almost all the languages spoken by human being. They are just expanding every year. They are releasing some, every year 2-3 versions are released. Latest version about Unicode is Unicode 14. You can refer to that internet. Okay, so character encoding identification system. Once character encoding identification is done, next step is to identify the language, the major language. Maybe because the reasons might be something may involve some text which is not encoded, or maybe that encode supports more than one particular language used in the same document. Okay, so the next step is language identification. And the next step, final step, is text sectioning. Text sectioning is about removing unwanted data. That is, if I have a image or a audio file or video files, they are not relevant in this particular document. So we want to eliminate all those things and retain only the text as a part of the final output, the document triage. This is about converting a digital set of digital files into well-defined text document. Okay, so that, as we have discussed, it involves character encoding identification. It is important for a machine to understand the characters of a natural language. Second thing is language identification. It is because to apply the language specific algorithms. Language specific algorithms are there. Suppose if I want to do word sense disambiguation, which language I want to do this one? Okay, so there are plenty of language specific applications, algorithms are there to choose them. And finally, text sectioning, to discard unwanted elements in the text. So what is the output that we get out of this document triage? Well-defined text corpus, organized by language, suitable for text segmentation. The next step, next stage, suitable for text segmentation and for further analysis. Okay, so this is a document triage and its output. This is the first stage in text pre-processing. The second stage is text segmentation. What is segmentation? Breaking a text into pieces. It is both word segmentation as well as sentence segmentation. Word segmentation also called as tokenization. So what we do is we identify word boundaries. If a sentence is given, we are going to break that sentence into smaller units. What are the smaller units? That smaller units called as tokens. So why do we need to do that? Because some applications or some processing requires to remove these stop words. For instance, we have the, that, there, this, was, the, am, all those stuff. These are all considered as stop words because they are helping us in structuring a sentence, but not in locating some answers. Okay, comparing one document with other document. Okay, they are not keywords because they are used everywhere. They're used in every document. Okay, but what we are looking for is this something, those words that are unique, that can be used to differentiate something. Okay, so that is why we need to do this tokenization process, and it is done by identifying word boundaries. So you may think it is very simple task, word boundaries. Okay, because we are not talking about English, we are talking about natural language as a whole. So that means we have a text in a particular language and we want to identify the boundaries. So word boundary means there are spaces between two words, right? In this sentence itself, it is space, done, space, by, space, identifying, and so on. But there are languages like Chinese, Mandarin languages. They don't have space between words, and of course they are not using words made up of characters, but character act as a word. So there are languages. So we need to do that part. Generic tasks that we are discussing. Word segmentation is required. Another part about word segmentation is normalization. Normalization is, for instance, you take this one, Mr. dot represents Mr. Mr. also represents Mr. Mr. is also representing Mr. So we want to convert into a canonical normalized form. I just want to have one particular form which has to be uniformly followed, because if it is part of the corpus generation, and corpus must use the uniformity, but follow the uniformity. For such things we want to normalize. Not only this normalization, but stemming and lemmatization. These are also some of the normalization processes. Okay, so we want to do that. That is, word segmentation is one, and sentence segmentation. What is the same thing? Like word segmentation, like finding a word by identifying its boundaries, we are identifying sentence by identifying its boundaries. But compared to this one, sentence boundaries, we have so many complications, like a sentence might be end with a dot, or maybe a space, or maybe a quotation marks. Okay, because sentence means not a complete sentence. We are also talking about phrases end with comma, semicolon, right? Maybe a hyphen might be used as a punctuation. So like all these things we want to identify. This is text segmentation. And we don't do that. Suppose if I'm going for our word segmentation, I don't say that sentence segmentation is not done. Both are done together. Most of the cases, most of the time, we are doing it together. So this is the second stage of the text pre-processing. Okay. So in text pre-processing as a whole, it involves everything. It involves tokenization and segmentation. And as a part, what we are getting, we will try to normalize. And of course, we want to remove the noises as well. Suppose some characters is not understandable. If it is not part of the particular encoding is available, so we can discard it. We can discard it. We can just consider them as an outlier, and we can throw them away. So like this, the text processing is important step, and these are all the steps that are interrelated, right? So when it comes to tokenization, that's what we have discussed. It is a process that splits an input sequence into so-called tokens. The reason is useful for semantic processing. And a token means, I can say it's a word segmentation, or sentence segmentation, or paragraph segmentation, and so on. So in some other texts, it may be referred as text segmentation or analysis, right? So breaking a stream of input text into words and sentences for subsequent processing is called tokenization, right? Token normalization. I mentioned that Mr. Mr. dot, Mr. all these things. And a part of that, we have many more things. For example, converting all text to the same case. For example, I mentioned character encoding. ASCII character is used. ASCII character, we have separate numbers for small case letters and separate numbers for capital case letters. Okay. So in that case, capital A is represented differently, small a is represented differently. So, but anyhow, when it comes to semantic meaning or something like that, it is all the same. Okay, so once we want to convert that also. Okay, so converting all text to the same case, whether it is upper or lower, convert everything into upper character or everything into lower character. Okay, removing punctuations. Suppose if apostrophe is used, or quotation marks used, or comma used. So all these punctuations, whether it is necessary or not, removing them, converting numbers to the equivalent forms, and so on. There are many things to do that part of normalization, right? Converting numbers to their word formats. In some documents, they are writing one day before. They write ONE 1 day before. In another document, you see that same thing, 5 days before. 5 in number is used 5 days before. Now you want to unify that so that you can use these numbers can be represented in text and so on. Okay, so that is, so many things are the normalization process, and putting all words on equal footing and allows processing to proceed uniformly is also a normalization. I told you stemming and lemmatization. This is also normalization process, because what we use in the text is a surface form. We want to find the root form of that surface text. Okay, for example, normalization. Normalization is the surface form of the word. What is the normalize? Normalize is the word, the verb. Like that, to find, that is also normalization process. So we already discussed a little bit about stemming. Stemming is a process of removing and replacing affixes. Okay, so there is a mistake. Affixes to get the root form of the word. So what does it mean? Affixes mean affixes could be prefix, suffix, infix, circumfix. So prefix is the word bound morpheme we discussed. We have bound morpheme. We have the stem, right? Free morpheme. Stem is called as free morpheme. So free morpheme, with free morpheme, if you add bound morpheme, where we can add as per the language rules, we can add it in anywhere. I can add it in a front as a prefix, or at the end as a suffix, or in the middle. There are some languages. European languages, I hope it is Turkish or French, I'm not sure. There they include the word morphemes in between to come up with a different meaning, right? So this can happen. Or circumfix, I can add both sides, both front as well as at the end. Such things can happen in a word. So cutting down these suffixes, cutting down these affixes from a given word and to find its root form is called stemming. Of course, lemmatization does the same thing. What is the difference is stemming is the most cruel way. What we do is we have a language and we have the usage of particular language. So how a word can be inflected. There are two different things. One is inflection, the other one is derivation. So inflection is the word by adding with some more bound morphemes, it it does not change the meaning, it changed into a different surface form, right? For example, eat, if I add s with eat, then it becomes eats. Okay, so to represent the tense and so on, that kind of thing is inflection. But when I add something, suppose if I add eat with yes, then it becomes eats, and both eat and eats, both a form of verb, both are under the verb category, right? But there are some words where I'm going to add these bound morphemes. Okay, then it entirely changes the word category. For example, computer. Computer. What is the surface form? Surface form is computer. How did we arrive at compute plus r? The bound morpheme r is added with compute, it becomes computer, right? But when I add r with compute, so compute, which is a verb, becomes a noun computer, right? So like that, there are changes which is called the derivation form. Okay, so like this is possible, and we know this for every language if you want to develop a stemmer, and these rules are exactly used to cut down the unnecessary portion from a word, from a surface form to find its root form. And due to this process, we may get the correct root form or not. That is possible in case of stemming, right? So carrying, carrying. If I use this carrying, the stemmer to process this one, it process by cutting down the last portion. A word end with ing, remove that ing. Ing is removed, I'll get a meaning carry. Correct word. If the word is carried, carried, now what do we do? It ends with ed, cut down the ed portion. Now what will I have? Carri, which is actually not the actual spelling, but still we accept that. That is stemming, but the same thing, it is done better by lemmatization process. So lemmatization process is related to stemming, differing that it's able to capture a canonical form based on a word lemma, the meaning, the actual base of a word. Based on that one, we are doing that. For example, better, if you give better, then the base form of better is good. Like that, we are able to identify. So it lemmatization process, same like stemming, but it returns a base form or dictionary form of a word, which is known as lemma. Right. So this link refers to the Wikipedia source for what is lemmatization. It is a procedural way of removing the bound morphemes from an inflected or derivational word, derivationally changed words into its root form. Okay, it does this in a uh, uh, procedural way. It considers, of course, it considers the rules plus the vocabulary, the dictionary. It's a dictionary form, right? So it works like that, lemmatization process. So goal of both stemming and lemmatization is reduce inflectional forms and sometimes derivationally related forms of a word to a common base form. I just discussed what is inflectional, what is derivational. Now am, are, is will be converted into be, car, cars, car apostrophe s, cars apostrophe s, all are converted into car. So for instance, the input sentence, which looks like this, the boys' cars are different colors, will be converted into like this after doing these basic steps, right? The character encoding, it's very, very important. So encoding is a process of putting a sequence of characters, okay, which is that is what we want to encode, symbols, punctuation, letters, which are used in a particular language so that the system can understand. So character is the smallest unit of the writing system of any languages, and character encoding is the way that letter, digits and other binary symbols expressed as a binary value that a computer can understand. That's what character encoding is about. We know ASCII was the first character encoding standard. It's a character set defined using 128 different alphanumeric characters that includes capital letters, small letter alphabet of English, plus numbers, plus some special characters. Then another one is UTF, Unicode. Unicode is another one which is covering almost all the characters and symbol in the world. That's the ultimate aim. They are doing it. They are doing it. Almost everything is added, included. If you consider any language, so recent years, before 4 5 years back, 5 10 years back, people started developing the character set for their own language. Then they would make it available as a font. Okay, so what will happen? This font will be utilized, will be added with their computer so that that can be understood by the compilers, by the text processing softwares that they have installed in their machines. So it can be shown. It can be shown in the screen. The text can be shown. Processing is also difficult. Everybody individually they are developing that one. Nowadays it is part of this uniform Unicode. So a major aim is to use it over the internet. So if it is being used over the internet, then everybody is understandable. Everything is understandable in every machine. So that's the idea of this character encoding. So UTF is one such set. About ASCII character set, it is 1 to 127. Numbers actually 1 to 127 is to represent all characters as well as a special character as per the ASCII character. What does it mean? We have 1 byte. 1 byte. 1 byte means how many bits? 8 bits are used for representing an English character. For instance, 8 bits, that is 1 byte, is used for representing an English character. That means we have an ASCII code. It's a table. It with a value, the decimal value 1 is representing one particular character, and like this. So what does it mean? Out of these 8 bits in a byte, only 7 bits are used, right? 7 bits, maximum 27, right? So table has 128 characters from 0 to 127. That means only 7 bits are used. How do I say that 7 bits are used? From 0 0 0 0, all 7 bits from 0, all 7 bits to 1, all 7 bits, 1 1 1 1 1 1 1 1. So what is the maximum value? It's 127. Okay, so that way a number is given assigned with a, so a character is assigned with a number, right? ASCII number. So ASCII value is used to process the text. Okay, but that is very, very small part, very, very small part. Here 7 bits are sufficient to represent a character in ASCII. However, most computer reserves 1 byte, 1 byte only. Suppose you might have done a lab, database lab. So what you do is you want to store names. Okay, you might have defined a attribute name is a varchar of 30. So what is that varchar of 30? So maximum size of this value can go up to 30 characters. So how much memory it occupies? 30 bytes. That means system allocates 1 byte per letter. Like this they are using it. And we have come up with some of these IBM mainframes started using another code, FCD code. Okay, and what we expect is we need more than that. We need more than that. So Unicode came into existence, standard for the consistent encoding, representation, and handling of text expressed in most of the writing system in the world. Okay, most of the OSs also support Unicode. Instead of following ASCII code, they have ASCII code and character encoding as well as Unicode and character encoding automatically built with the operating systems, so that most of these texts can be understood automatically. Especially it is used in the internet. Okay, internet. So Unicode is required for international document and data interchange, and some languages, Java, C Sharp, Perl, Python, they're also able to process this Unicode. And of course, we need this to be understandable by markup languages, right? HTML, XML, because they are we are using them to define the internet. Like this, they are used. And what we have, I told you, uh, we have almost all the languages are represented using Unicode. So it is used in internet. Any online documents you can easily view in your machine also. You might have seen that. Suppose if you want to type something using a Windows, Microsoft Word 7 or 2000, something like this, right? 2010. Uh, you may not be able to type in a particular foreign language. The system may not accept your character set. But on the other hand, the same time, in the same machine, you can see the browser in any language. Okay, so that is the purpose of this Unicode. Okay, so universal interchange, information interchange is required. Okay, and but initially what we have started with is, we have started with 8 byte. Okay, so that, sorry, 8 bit, that is 1 byte. UTF 8 8-bit encoding. And 8-bit encoding, how much? 8 complete 8 bytes, complete 8 bits we were used for encoding the different characters into a character encoding set. Later we understood it is not enough, because there are plenty of characters, okay, thousands of characters used in Chinese languages, and we need to accommodate everything, because each character is a word kind of thing is used in that languages. So we need more space. So then we have UTF 16, right? That means 16 bits. It uses 16 bits to represent a character. Then UTF 32 is there. UTF 32, it uses 32 bits to represent a character, and so on. Okay, so we'll discuss more on this during the next lecture, right? Okay. So any doubts? Any doubts so far?
Can you say
Sir, yes.
which character is used for English?
Each character.
No, sir. Character in code
Hmm.
used for.
Your voice is breaking. Each character in character encoding.
So used for English language, sir.
Which is for English language? Which one you are asking about in English language? No, pa. Unicode. We are asking about Unicode or English language. I don't understand your question.
So which character encoding used for English language?
Character encoding is for systems to understand any language.
Yes, sir.
Okay.
Yes.
Not only English. The
Okay.
system have to understand the English, the language, no, the character set.
Yes.
So what is the type, what you are typing? The system may not understand that, right?
Yes,
So
sir.
it can understand only zeros and ones. So what we do is, we take a decimal number, we assign the decimal to number to a particular character in a particular language, in any languages. It's like a table. It's like a table. So if I say this is the number, this is the particular character set, or this is a particular language, like this is for some reasons. Okay, not for typing in word. It's not required. Word, you can type it in ASCII characters, so more than enough. But several other symbols, what are the symbols given in the symbol table, can be included here. We need some way to represent them, and so on. Right?
Thank
Yeah. So you just go through your word file, huh? Open the word software, text processing unit. You just verify what are the things are available. Why do we need this processing, character encoding and all. You can understand by using this basic word itself. Whatever you can type with word cannot be typed with notepad. It will not support all the character encoding, right? Okay. So any doubts?